Hi, Math 206 students. We are entering into more constructions and wrapping up Chapter 12. So what we'll focus on now is constructing parallel lines and angle bisectors and perpendicular lines. And we'll discuss properties for angle bisectors and also end with an interesting construction. So first, we have two separate methods for constructing parallel lines. That is, if I give you one line and a point, we'll construct a line that's parallel to the given one through the point. And the method that we're going to use is the rhombus method. So rhombuses or rhombi are great tools for doing constructions because number one, they're really easy to construct. All you have to do is make sure that all of the sides are the same. So four sides all the same length, and then automatically it's a rhombus. And they have really interesting properties. The first property that we're going to use is the fact that opposite sides are parallel. So if you imagine that the given line is one side of the rhombus, then the top of the rhombus will be parallel to the given side. Another interesting property is that the diagonals bisect each angle. So every diagonal bisects the vertex angle. And also, the diagonals of a rhombus are perpendicular bisectors of each other. So these are all great properties, and we'll use them, we'll kind of exploit them to do constructions. So first, suppose I'm given a line and a point, and I'm trying to construct the line parallel to L through P. So the first thing I'm going to do is draw in a transversal line that intersects the line that I'm given and that goes through the point. So I'll imagine that this distance here is this is one side of my rhombus. So what I need to do is measure what's that distance and copy it over to all the other, from all the other vertices. So I'll take my compass and I'll use it to measure the distance from, and I'll call this point here A. Measure the distance from A to P. And I'll copy that distance over onto the line by drawing an arc. Okay, that'll give me a new intersection point. You can call that X if you like. So now I've got these two sides of my rhombus are exactly the same. Now I'll copy that same length, so don't move your compass, from point X and also from point P to see where those intersect, and that will be my last vertex. So I'll draw an arc from X and also an arc from P, and this intersection point right there, you can call that Y if you like. That will be the fourth vertex in our rhombus. So all I need to do is connect the point P with the point Y. And then the line that I get will be parallel to the line that I was given. So I just want to highlight here for you the rhombus that we constructed. That was my first length that I constructed just by drawing this random line through the point intersecting the line that I was given. And then I made sure that this length was the same as that length. And then I used my compass to measure out this length and this length until they met at the vertex Y. So this right here is a rhombus, and the opposite sides of a rhombus are parallel, therefore the lines are parallel. Let's go through another construction. This is the corresponding angle method. This method just allows you to construct a line parallel to the given line through a point by creating an angle through the point in the line, and then copying that angle up to point P. And we've done that construction a few times where we've copied an angle, so we'll go through that relatively quickly. So step one here, step one is just to draw a random line through the point P that will intersect the line L. So this is the angle that I want to copy over. So let's remember how that construction goes. Put the compass point at my vertex. And it doesn't matter what you set your compass arms to. So I'll set it somewhere. Draw an arc and copy that arc over to your point. Now we need to measure the opening made by my angle. So I'll take my compass and measure the distance between these two intersection points. And now I need to copy that distance up here. But notice I need to know where to put my compass point, and the only reference I have here is this intersection point. So let me just turn my compass around. Put the compass point at that intersection point and draw an arc. So there is my new intersection point. This point should lie on the line. So now I can go through and connect the point to that intersection. And that gives me a line parallel to the one given through that point. And that's all because this angle here, I copied that angle up to here. And corresponding angles are congruent if and only if you have parallel lines. All right, let's do one more construction that uses properties of rhombuses. The construction is angle bisectors. So the property that we're using here, and I referenced this earlier, is that if you have a rhombus, again, opposite sides are all parallel, all sides have the same length, and the diagonals of a rhombus bisect the vertex angle. So this angle and that angle are the same, and it's actually the same as these two angles. The other diagonal bisects the other two vertex angles. And again, what does it mean to bisect an angle? It means to chop an angle into two adjacent angles that have exactly the same measure. All right, so what I'm going to imagine here is if you're given an angle, just construct a little rhombus so that these are two sides of your rhombus. And once you have this last vertex, you can just go ahead and connect the dots from the vertex here to the vertex there, and that will bisect the angle for you. So that's going to be our method. Step one, I'm given an angle. I need to set a length for the rhombus that I'm going to construct. So it doesn't matter what length you set, any length, but once I have it set, I'm going to keep it. So, set my compass, and I will draw an arc. That arc gives me two intersection points. I can call them B and C if I like. And now I need to find the fourth vertex. So this is 3 vertices. Fourth vertex will be somewhere out here. Right? So use that same distance. Set the compass at B. And let me use a different color. Make sure that I didn't change my compass arms at all. Okay. Set the point at B and draw an arc. and then set the point at C and draw an arc. So that gives me another intersection point. So that's like the fourth vertex in my rhombus. I can call that D if I like. Let me connect the opposite vertices. And this will be the diagonal of the rhombus, which bisects the vertex angle. And let me highlight the rhombus that I drew here. Here are two sides of the rhombus. The other two sides of the rhombus are here and there. And by construction, I didn't change the length made by my compass. So this side and this side and this side and this side are all the same length. Therefore, it's a rhombus. And here's the diagonal that we created. So now I know that this chops the angle into two equal sized pieces.